Greetings to everyone. Myself, Dr. M. Harihanand, working as an associate professor in the Department of Civil Engineering in Mari Lakshman Reddy Institute of Technology and Management. It is an autonomous institution which is located at Dundikal, Hyderabad. I am handling the subject of surveying and geomatics for the second year civil engineering students. Now, today we are going to discuss about the problem related to height of instrument method and rise and fall method. We can go to the problem. So here the given data. This question has been asked by JNTUH in the year 2016. Okay. Now the question is the given data. The following consecutive readings were taken with the dumbbell level and 4-meter leveling staff on a continuously sloping ground at 30-meter interval. 0 and so here the given data is they have whatever the reading we have taken now, that is by using dumbbell level, and we have used 4-meter leveling staff. So it is on a sloping ground. The interval between one place of staff reading to another place of staff is 30 meter. Okay. So likewise they have continued. So the data, that is the ground data in the leveling staff, they have given that 0.680, 1.455, 1.855, 2.330, 2.885, 3.380, 1.055. So here the reading has been suddenly dropped. Okay, now from here to here it is continuously increasing. From here to here it is continuously increasing. After that it gets suddenly dropped. Okay, so this is called change point. This position is called change point, which means the instrument, the position of dumpy level has been changed from one place to another place. Okay, that is called change point. So this is change point number 1. Then we can continue. So 1.055, 1.860, 2.265, 3.540, 0.835. So here they have done another change point, CP2. And next 0.945, 1.530, and last reading 2.250. So first reading we can write in backside, and the last reading corresponding to the instrument position is at foresight. Similarly, this is change point. So this reading should be at backside and this reading should be at foresight. Similarly, this reading at backside and this reading should be at foresight. Okay, and whatever the reading in between that, those readings should be at intrasight. Okay, so now I am drawing the diagram for understanding purpose. So they have mentioned that the ground is sloping ground. Okay, so this is our sloping ground. So they have kept instrument somewhere here. Okay, so this is our instrument position, and they have done all the initial adjustment like setting up, leveling up, and elimination of parallax. After that they can keep the leveling staff at benchmark place. Okay, so if they given the benchmark value we can take, or else we can go for 100 as a benchmark. Okay, now they have given the RL of a starting point was 80.750. So this point we can take 80.750. Now the reading at first place is 0.680. So the height from the benchmark, that staff reading is 0.680. So next, after 30-meter interval, they have kept the staff. So here the ground to line of collimation height is 1.455. After 30-meter interval, they have kept the staff, so that the height from the ground to line of collimation is 1.855. Next, once again after 30 meter, they have placed the instrument and the height is 2.330. So from the ground to line of collimation height. Then another 30 meter. So in the next 30 meter, the ground to line of collimation height is 2.885. Okay, then last reading 3.380. Okay, so if I'm with respect to this point, that is our station point, okay, not a station point, this is our instrument point, okay, station STP, we can call it as STP, okay, this is our station point, okay, first. So if I am going to, our leveling staff height is 4 meters, so if I am going for another 4 meter, the height of leveling staff won't be matched, or we cannot see the reading, okay. Now then at that situation we have to go for change point, okay. Change point is nothing but shifting the instrument from this place to next place. At the time, wherever the last point of the leveling staff should not be changed, just we are going to interchange the instrument position, okay. Now from here to somewhere here, and we have to do all the initial adjustment so that the line of collimation become like this, okay. Then corresponding to this staff position, this is called change point. So this is our first change point, okay. So with respect to this position, at whatever the last staff reading, we have to take it once again in that place, okay, now without changing the staff position, so that we are getting the reading of 1.055. So likewise we have to continue our process, okay. Now so here the height of the staff is 1.055. So after 30 meter interval, the reading is 1.860. So next to that 2.265. Next to that the height of the staff reading from the ground to collimation line is 3.540. Then after we need to give the change point so that the instrument has been shifted from that position to another position, from there to here somewhere. Okay, at that time we never changed our staff position. So after doing all the initial adjustments, that is setting up, leveling up and elimination of parallax, we have to see the staff reading wherever we have taken at last. So in that places the ground to line of collimation height is 0.835. 0.835. Then after 0.945, then after 30 meter distance the reading is 1.530. 1.530. And at last it is 2.250. 2.250. So this is the height with respect to ground to the line of collimation. Okay, now the given data, that is carry out reduction of heights by the collimation method. Okay, we have to book the level in the form of height of instrument or height of collimation method that they are asking. Okay, now so now this is the table which have serial number, backside, interside and foresight, along with that height of instrument, reduced level and remark. Okay, so now we have to book those level whatever we have taken here. Okay, so 0.680, that is the first ever reading, so we could take that reading in the backside. So 0.680. Okay, corresponding to that, this is called benchmark and the reading of benchmark is 80.750. so that we have to note down. So 80.750 is the RL of first point. Okay, 750, and in the remark we have to write this is benchmark reading. So in short form, benchmark, BM. So second, next reading. Okay, 1.455, which is at interside. 1.455. So next 1.855. 1.855. Next 2.330. 2.330. This is our fourth reading. And next 2.885. 2.885. Next 3.380. So with respect to this position of instrument, okay, this is the last point. So we have to write this 3.380 at foresight. So 3.380, which can be written at in the foresight. So this is our sixth reading. So next change point. So with respect to this CP1, the first reading is 1.055. That can be written in the backside. 1.055. So So the next reading 1.860, which can be written in the intersite 1.860. Next 2.265, 2.265. So next to that 3.540. So with respect to this CP1, this is the last reading. So which that can be written in foresight 3.540. So this is 7th reading, this is 8th reading, and this is 9th reading. So in the remark, this is CP1, change point 1. So this is change point 2. So now the instrument has been shifted from here to somewhere here. So this is called CP2. So with respect to change point 2, the first reading is 0.835, which can be written at backside. So 0.835. 0.835. So next 0.945. 0.945. This is 10th reading and 11th. 1.530. 1.530. This is the 11th reading and last. With respect to this CP2, this is the last reading, that is 2.250. That can be written in foresight 2.250. This is the 12th reading. Okay, so this is called whatever we have done. Okay, now this is called booking of level. Next we have to go for calculation, that is reduced level of those points, that means those grounds. So this is our ground points, each point. Okay, so we have to calculate this ground station of, that is RL of ground station. Okay, now for that, how the way we have to calculate means, first we have to identify height of instrument or height of collimation. This is nothing but height of this line. Okay, height of this line is called height of collimation. How the way we have to calculate? So simply we can calculate it from benchmark reading. So benchmark reading plus this height of leveling stuff over the benchmark. Okay, now that gives the height of collimation or height of instrument. So 80.750 plus 0.680 will give the height of instrument. So 81.430 is our height of instrument for the first position. 81.430 is our height of instrument. Okay, now we have to calculate reduced level of remaining staff points. Okay, so how the way? This 81.430 minus 1.455 gives the RL of this point. Okay, similarly 81.430 minus 1.855, that gives the height of this in RL. Okay, so likewise, so this reading we are going to deduct it again. So now we can go to the problem. So 81.430 minus 1.455, 79.975, 79.975. Then 81.430 minus 1.855, 79.575. Next 81.430 minus 2.330, so 79.100. 79.100. Next 81.430 minus 2.885, 78.545, 78.545. So next 81.430 minus 3.380, that is 78.050. So in the figure I can explain. So 81.430 minus this 3.380, that gives the height or RL of this point. Okay, this is nothing but 78.050. So if I need the height of instrument with respect to this position, how I can get it? This 78.050 plus this staff reading 1.055. So 78.050 plus 1.055, that gives the answer of 79.105. So now I can get the remaining point RLs. This 79.105 minus 1.860, that gives the RL of this point. Likewise, we have to calculate for everything. So 78.050 plus 1.055 gives the answer of 79.105. So this is the height of instrument with respect to the CP1. So now onwards we have to deduct from this height of instrument. Okay, so 79.105 minus 1.860, that gives the answer of 77.245. Similarly, 79.105 minus 2.265, 76.840. 79.105 minus 3.540, that gives 75.565, 75.565. So 75 point 75.565 is our RL of point here. Okay, now I need the height of instrument or line of collimation here. That gives, which means 75.565 plus this 0.835, that will give the height of my instrument position with respect to CP2. So 76.400. So now if I need this RL, how can I get it? This 76.400 minus this height. If I am going to deduct this, I can get it. So 76.400 minus 0.945 gives the answer of 75.455. So here it is 76.100. The height of instrument with respect to the CP 2, 76.400. Sorry. So 76.400 minus 0.945 gives the answer of 75.455. So next to RL, 76.400 minus 1.530, that gives 74.870. Then next 76.400 minus 2.250, that gives the answer of 74.15. So this is the calculation part with respect to the given data. So this is our given data. Whatever the way we can write it here now, that is called booking of level. Okay, and this is called reduction of level or reduced level calculation. Okay. So now we have to go for arithmetic check part. Okay, now so before that we will see the output should be like this. Okay, so now our arithmetic check with respect to height of instrument or height of collimation method, that is sum of backside minus sum of foresight, should be equal to last RL minus first RL. So if I am going to sum up these three values, I am getting the value of 2.570. Similarly, sum of foresight readings, if I am going to add all these three values, then I am getting 9.170. So this difference between these two readings is minus 6.600. Okay, similarly my first RL, okay, last RL minus first RL, last RL value is 74.150 minus my first RL 80.750, that gives the answer of minus 6.600. So left hand side should be equal to right hand side, so that our calculation part and whatever the reading we have taken in the field, those should be correct. Okay, hence proved, that's why hence okay. So this is our final value of tabulation. Okay, now the same problem we can solve with the help of a rise and fall method. Okay, so let's go for rise and fall method. Same the way we have to book all the levels. Okay, so whatever the reading we can have here, okay, now we can take the same. So first I will write all these values. So 0.860, sorry, 0.680, 1.455, 1.855. So the booking of level won't change. Okay, fourth one 2.330, sorry, fourth one 2.330, fifth one 2.885, sixth one This is the last reading with respect to the first station point, 3.380. That can be written in four sides, 3.380. So the next reading with respect to the change point 1 is 1.055. 1.860, 2.265, 3.540. This is the reading which can be taken at last with respect to the change point 1 position. So that should be written in foresight. Then the instrument has been shifted into another place. With respect to the change point 2, we are taking the first value, that is 0.835. That can be written in the back side. 0.945, 1.530, and finally with respect to change point 2 position, we have taken the reading of 2.25. that can be written under the foresight reading, 2.250. So this is called booking of level. Now we have to go for calculation part. Here the reduced level of the first reading they have given as 80.750. So 80.750 is our benchmark reading, and this is our change point 1 position, so we can written as CP1. This is our change point 2, so we have to written in the remark as CP2. Now we can go for calculation part. Okay, so here there will be the continuity from the first reading to last reading. Okay, so that we are going to look at first, which means I am going to deduct the values from the first value to second value. I am going to deduct. Okay, now if this value comes in minus, means I have to written in fall. Okay, if this reading, this deduction will come in positive, then I have to write in the rise column. Okay, now so this is the criteria we are going to follow in the rise and fall method. Okay, so first 0.680 minus 1.455, I am getting the answer of minus 0.775. so minus indicates fall. Okay, now so with respect to this ground level, this ground should have underneath the position. Okay, now so that's why we are giving the minus. Okay, so minus 0.775, so that we are going to return in fall. Then next 1.455 minus 1.885, 855, so 1.455 minus 1.855, minus 0.4 I am getting, so that reading also in minus, so I am going to return in fall. So 1.855 minus 2.300, 1.855 minus 2.330, minus 0.475, so minus indicates falling of ground, so I have to write under the column of fall, the reading is 0.475. So 2.330 minus 2.885, 2.330 minus 2.885, that gives minus 0.555. So this is also in fall. Actually in given data they have mentioned the ground is sloping ground. Okay, so from the first reading to last reading it is sloping ground, so we have to get all the values in minus, so that all the values we have to write under the column of fall. Okay, this is for our notification I am telling. Okay, next to 2.885 minus 3.380. That gives minus 0.490, 495. Next 1.055 minus 1.860, 0.805. Next 1.860 minus 2.265 minus 0.405. Next 2.265 minus 3.540 minus 1.275. Next 0.835 minus 0.945. Zero 0.110, that is also in minus, so we have to write under the column of fall. Next 0.945 minus 1.530, which gives minus 0.585. At last 1.530 minus 2.250, that gives the answer of 0.720, that is also minus, so we have to write under the column of fall. Okay, now we have to come for reduced level calculation. Okay, so our reduced level for the first RL is 80.750. So we have to calculate for the remaining points. So very beginning I said in rise and fall method we have the continuity. So whatever the reading we got it now, so we have to, if it is rise we have to add, if it is fall we have to deduct from the reduced level whichever is at previous. Okay, so 80.750 minus 0.775, that gives the answer of 79.975. Okay, next from this reading there will be the continuity. So from this reading whatever we are going to deduct or add, so here it is fall, so we have to deduct. So 79.975 minus 0.04, that gives the answer of 79.575. So next from this reading we have to deduct 0.475. So 79 minus 79.575 minus 0.475, that gives the answer of 7900. 79.100. So next 79.100 minus 0.555, that gives the answer of 78.545. Next 78.545 minus 4.495, that gives the answer of 78.05. So 78.050 minus 0.805, that gives the answer of 77.245. So 77.245 minus 0.405 gives the answer of 76.840. Next, 76.840 minus 1.275. 75.565. So next, 75.565 minus 0.110. 75.455. Next, 75.455 minus 0.585. 74.870. So last, 74.870 minus 0.720, that gives the answer of 74.15. Okay, now we can check this RL value with respect to height of collimation method. Okay, so our first RL is 80.750, same. Second is 79.975, same. Okay, third one is 79.575, same. Fourth one is 79.100, same. Fifth one is 78.545, same. Here 78.050, here also. Here 77.245, 77.245. Here 76.840, here 76.840. Here 75.565, here also 76.565. Here 75.455, here also 75.455. Here it is 74.870, here also 74.870. Here it is 74.150 for last RL, here also 74.150 last RL value. Okay, now we have to tabulate like this. Okay, so I already said if it is minus sign we have to write under fall column, if it is plus then we have to write under rise column. Okay, while going for a reduced level, if it is plus you have to add, if it is rise you have to add, if it is fall you have to deduct. Okay, now the arithmetic check for the rise and fall method is sum of backside minus sum of foresight, which is equal to sum of rise minus sum of fall, that is equal to last RL minus first RL. So the sum of backside reading is 2.570 and sum of foresight reading is 9.170. Their difference is minus 6.660. Okay, similarly sum of rise column there is no reading, so 0. Sum of fall column it should be minus 6.600 we are getting, so their difference becomes minus 6.600. Okay, then last RL is 74.150 minus first RL is 80.750, that difference becomes minus 6.600. So here we are satisfying with respect to all the values, so hence it is okay. So whatever the reading we have taken and whatever the calculation we have done, all are correct. Okay, so if we are getting any difference among these values, okay, now first we have to check our table formation, that is booking the level. Okay, now after that we have to go for either rise or fall or height of instrument. Okay, now that we have to check it. If everything is correct, then we have to go for reduced level calculation. Okay, now even that also correct, and if we are getting the difference in this arithmetic check, then we have to go for field, and once again we have to take the reading. That is the proper solution for this. Okay, so in this problem we have done the first, we have find the solution for the first category, first question. Then second question, that is determine the gradient of the line joining the first and last point. Okay, now so for this, so what is the RL of this point? 80.750. What is the RL of the last point? Okay, now that is 74.150. 74.150. So their difference is 6.600. Okay, now, and the distance covered from the first point to last point is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So totally we have covered 11 intervals. So 11 into 30. So the gradient is the formula. Okay, now what is the grade? How we have to calculate the gradient? So gradient, which is equal to the last RL minus first RL divided by distance covered. Last RL divided by distance covered. That will give the gradient. Distance covered total. Okay, so 6.6 divided by 11 into 30, that gives 0.02. Okay, so 0.02. So 1 divided by this 0.02 gives 50. So we have to write gradient in terms of 1 in 50. So this is the answer for our second question. Okay. Thank you all for watching this video.